So finally, we are going to practice using what's called dimensional analysis to solve stoichiometry problems. You don't have to use this process. For some of you, this will make the problems easier to solve, but if you prefer to do the process as individual steps, as we've done earlier, you can continue to do the problems that way. So dimensional analysis allows us to combine most of the steps for stoichiometry into one math problem so that we can enter the numbers into our calculator all at once and get a final answer. I'm going to demonstrate how to use stoichiometry to solve this problem. So we know that we have to start by balancing the equation. We did that earlier, so I'm just going to fill in the coefficients, 2, 2, and 1. In this case, the given information is that 50 grams of water is produced. So water is going to be A, and a product can be the given information. We're asked how much hydrogen peroxide reacted. So in this case, hydrogen peroxide will be B, the thing we're looking for. We need to start with the mass of A, which is 50 grams. And we'll need to know the molar mass of A. So water has 2 hydrogen atoms and 1 oxygen atom, so the molar mass of water is going to be 2 times 1 plus 16, which gives us 18 grams per mole. We'll also find the molar mass of B, since we know we'll need that later. That was hydrogen peroxide. We just calculated that one. That's 2 times 1 plus 2 times 16, which gives us 34 grams per mole. And then we're just going to set up all the ratios in order. This is one of the reasons we've been using ratios all along. We're going to start with the mass of A, which is 50 grams. And we're going to multiply by the ratio of grams of A per mole. So that would be 18 grams per mole. We're going to put the 18 grams on the bottom because we want the units to cancel. And if we're starting with grams, we need to put grams on the bottom. We're going to have 1 mole of A on the top. And then before we do the calculation, we're going to set up the next step. If we have moles of A on the top, that means we need moles of A on the bottom. But this time we're going to use our ratio of A to B. So in this case, moles of A will be a 2. That means there's 2 moles of A for every 2 moles of B. If it was easier to write with this pointer, I might also include grams of A, put an A here and an A here. Moles of A, put an A here and an A here. Now we have moles of B, so on the bottom we're going to have moles of B. And on the top we're going to have grams of B, since that's what we're looking for. What do we know about grams per mole of B? We know there's 34 grams in 1 mole, so we're going to fill in 34 on the top and 1 mole on the bottom. And then to get our answer, we're going to multiply all the way across on the top. So that's going to look like 50 times 1 times 2 times 34, which gives me 3,400. And we're going to multiply all the way across on the bottom. So that looks like 18 grams times 2 times 1. So that gives us 36. And then I'm going to divide the number that I got on the top by the number I got on the bottom. And in this case, my answer is 94.4, or you could round to 94 grams of hydrogen peroxide. So this time we use stoichiometry to calculate the amount of hydrogen peroxide that we expect was reacted if we produced 50 grams of water. If you wanted to do some simple math, that would also mean that if there were 94.4 grams of hydrogen peroxide and 50 grams of water were produced, we could subtract to find that 44.4 grams of oxygen were also produced, in case you want to try that one out.